So in this lesson, we're going to look at series and parallel circuits. And this, again, sectional learning, it's working towards this learning outcome. So students should be able to design and build simple electronic circuits. So these are two particular types of circuits, and we're going to look at some of the characteristics with these two types of circuits. So let's have a look. So the first one, so this is what's called an in-series or series circuit. Okay, so this is the diagram for what it looks like. So, and this is what it looks like here. So you have a battery, and then you have your two components. In this case, they're bulbs. Okay, so they're taking electrical energy and they're turning them into light energy. And what we can see here is that both of the bulbs are in series. So that means that they're kind of lined up. So if you think about the current, the electricity is going to flow through both of these bulbs, okay, from the battery through both of the bulbs, and it's going to do it in series. So in a series circuit, all components are connected end to end. So we can see that they're connected end to end, forming a single path for the current to flow. So there's just one path that the current can flow through. In a series circuit, the sum of the voltage across each bulb is equal to the total voltage of the battery. So if you were to check the voltage of this bulb and the voltage of this bulb, what you'll find is the two of them will add up to the sum of the voltage of the battery. So if the battery was a 9-volt battery, let's say, the voltage on, if you check the voltage on this light, it's going to be 4.5. If you check it on this light, it's going to be 4.5. And then when you add the two of them together, they're the combined voltage of the battery. So essentially what's happening is the pushing power or the voltage is getting, like each light is not getting the full voltage, if you like, from the battery. In series circuit, both bulbs have the same current flowing through them and have less current than if they were connected in parallel. So because the voltage is essentially halved, they'll both have the same current flowing through them, but they won't have as much as can be provided for by the battery. So both have the same current flowing through them and have less current than if they were connected in parallel. If a bulb fails in a series circuit, the circuit is broken and the other bulb doesn't light. So for example, if this bulb, let's say, burns out, then this bulb is not going to light. So the circuit essentially will be broken. So let's have a look at this, at an example of this, an in-series circuit. Okay, so if we have a look here, and I'll just take away these voltmeters. Well, actually, I'll just leave them there for now. Okay, so what we have a battery, and then we have our circuit, and then we have our two bulbs, and they are emitting light. And what we can see is that they're in series with each other. Okay, so they're on the same path with each other. So what's happening is you're getting the electricity, that's the electrons that are flowing around through the battery or through the light, and we have electrical energy being turned into light energy. So if we have a look here and if we check the voltage of the battery, we can see that the voltage of the battery is 9 volts. Now, these are two voltmeters here, and what they're doing is they're checking the voltage across each of the bulbs. And what we can see is that each of the bulbs only gets half of the voltage from the battery. So the battery is 9 volts, so therefore each of these bulbs the voltage across it is 4.5 volts, and this is 4.5 volts as well. Okay, so you're not getting neither battery is getting the full voltage of the battery, it's getting half of it. So as a result of that, it's not shining as brightly as it could be. Now, if we take away these voltmeters and we just look at the circuit, so this is an in-series circuit. And now if, let's say, for example, this bulb, it stops working, so what that's going to do is it's going to break the circuit, and then what's going to happen is both lights are going to go out. Okay, so you're not going to get electricity flowing through either of the circuits. Okay, so that's what's called in series, and they're some of the characteristics of an in series. So the voltage across each of the bulbs is going to be half of the total voltage of the battery. Or another way to think about it is if you add up the voltage across both of the bulbs, it'll equal to the voltage of the battery. So the next type of series is what's called in parallel circuit. So basically each of the components are parallel to each other. So here they're in series with each other, here they're parallel to each other. So we can see this in the diagram. We have our battery and then we have our two components, and they're parallel to each other. So in a parallel circuit, each bulb is wired to the battery in a separate loop. So we can see here, here's the battery, and we have one loop here, and then we have another loop here. And as a result of that, each bulb will have the full voltage of the battery across each bulb, and more current will flow through each bulb than if they were connected in series. And if a bulb fails in a parallel circuit, the other bulb continues to light. Okay, so these are some of the advantages of a parallel circuit. So let's look at this in a bit more detail. So here we have a battery and we have our two circuits and we have our two bulbs. Now what we notice is that if we check the voltage of this, so again it's a 9-volt battery, but what we can see, so we have essentially the same components like we have here, but we can see that in this arrangement or this setup, the light bulbs are emitting more light. Okay, why are they emitting more light? Because each light bulb is getting the full voltage from the battery because they are wired up in parallel to each other. So again, we have the same components, but they're just arranged differently. And as a result, you have different outcomes. So if we look at the voltage is 9 volts of the battery, and if we check the voltage of either of these lights, we will see that they are getting the full, they're going to be getting the full voltage from the battery. So there's going to be 9 volts across. So we can see here we have 9 volts across this light here, and we're also going to have 9 volts across this one here. Okay, so the battery is 9 volts, as we can see, and when you wire it up like this, each light is going to get the full energy, if you like, or potential energy from the battery. Okay, when they're wired up like this. If we contrast that to when you wire it up in series, so if we have a look at, so we can see that if we check the power, or not the power, but the voltage across this light here, we can see it's only getting 4.5. It's only getting half of the voltage from the battery. And that's because the other half is going to this bulb here. So there's a benefit of wiring it up like this because you're getting the full force of the electrical energy coming from the voltage from the battery. Also then as well, for example, if this gets broken, okay, so we can see that it's broken. So this bulb goes out, but this bulb continues to light, okay, because both of them are on two separate loops. So we can see that it has an advantage, whereas over here, let's say if this light goes out, this light goes out as well. Okay, so let's just get rid of the voltmeters for now because we're finished with those. So if we think about the current then, so again, if we look at the current across this battery here, so it's only getting, or this light, it's only getting 4.5 or 0.45 amps. Okay, so there's 0.45 amps and the same over here as well. Whereas if we check this setup, we can see that there's more current or electricity flowing through the bulb. It's getting 0.9 amps, and this is getting 0.9, and the same down here as well. So, and the reason it's getting more current flowing through it is because each bulb is getting more of the voltage from the battery because it's set up in parallel in this arrangement. So that is an in-series circuit versus a parallel circuit. So it's important that you know the two types of circuits and you know the difference between both of them as well. So next I just want to look at, so when we start to think about creating our own circuits, we just want to kind of break it down into a process. So a useful way to think about it is, so electronic systems block diagrams shows the input, process and output of a system and helps circuit designers to select the correct components. So when you're building a circuit, you can think about this model here. So the circuit will have the inputs, it'll have a process, and then it'll have some kind of an output. So let's look at each of these in detail. The input is the trigger usually a switch or a sensor that makes the circuit do something. So when we're designing a circuit, you have this input, you have something that's going to start the circuit. So a really simple example of that is if we have a look at this circuit here, so an input will be the switch. So that means that in order to turn this circuit on, the person is going to have to provide some input, they're going to have to turn the switch on. Okay, it might not be a switch. You could use, for example, a light dependent resistor, or you could use a temperature dependent resistor either. And that could take in input from the environment, and that can either switch on or switch off the circuit. So that's what we mean by input. Okay, so you have this input. Then you have, so what's going to happen is that input is going to be processed in some way. So the process components take the input signal and direct it towards an output component. Process components can be resistors, transistors, integrated circuits, or microprocessors. Okay, so basically what's going to happen is if we think about the input here is going to be, you're going to turn the switch on and off. The output is going to be the light bulb is going to light. And then everything in between is the process. So for example, the battery is going to push the electrons around the circuit. The resistor is going to slow down the flow of the electricity, and then it's going to be presented, then the electrons will go to the lamp, and that will take the electrical energy and turn it into output light energy. So the output is a part of the circuit that does the work, such as a lamp lighting. So for example, so think about it when you're building a circuit, think about your input. So what's the input? Think about how the current is going to be processed when it goes through the circuit, and then think about what's the output going to be. So the input, turn the switch on, the output is the lamp is going to light up, the process is going to be the electrons are going to move through each of these components and get here to this component. So that's when you're thinking about a circuit, think about that input, process, and output model. So then to kind of break it down and look at it in a bit more detail, so again you have your input, you have your process, and then you have your output. So many input devices, such as if we have a look here, so what are some of the input devices that gets the circuit going? So you could have a simple switch, you could have something like this that's a light dependent resistor, you could have these guys here which are temperature dependent resistors, so they take an input, they're going to sense the temperature in the room, or you could have something like this which is a variable resistor. So as you turn this around, for example, it increases or decreases the flow of electricity through the circuit. So these are all kind of like your input devices. Then what's going to happen is the flow of electricity is going to be processed in a particular way. So you can have things like resistors, like this one here. So it resists the flow of electricity, or it slows it down. You could have something like this, a diode, so it lets the electricity flow in just one direction only. Or you could have a fuse, which basically monitors the flow of electricity, and if too much electricity is flown, in this case if it goes above 13 amps, it's going to stop the flow. So the electricity is being processed, so it is. And then once the input comes in and the electricity starts getting processed, it's going to move towards some kind of an output. So common output devices would be like a bulb, so it's going to take the electrical energy and turn it into light energy. So if you think about a lamp, it could be an LED. So for example, this could indicate whether something is on or off. For example, when you flick a switch, it could be taking the electrical energy and turn it into kinetic energy, like this. This is a motor. So basically, on the end of this, you could have a propeller. So once you've turned on the switch, the electrical energy is turned into the output of a motor, and it's going to start turning. Or it could be even turned into sound energy, like in this case it'll take the electrical energy and turn it into sound energy. So this is a buzzer. So just like common examples, if you think a simple circuit like a doorbell, so the input would be you press a button, okay, the electricity gets processed through a circuit that might have resistors and diodes and fuses on it, and then it's going to go to an output, which would be the electrical energy being turned into sound energy, into like a doorbell, for example. So that is the electronic system, and so we looked at parallel and in series circuits. and then we looked at the start of how to go about designing a circuit to take an input, process it, and then provide an output. Okay, thank you for listening.